Good evening. Um, I thought I made all these videos, and I think one of the videos I've never really made is a basic introduction on how the idle speed system actually works in the V8 cylinder suction engines. In general, this here what I'm demonstrating is primarily the 3.8, 5.0, 4.2 and 5.6 liter engines from 1980 on until 1991. But the principle of this is basically the same on the 4.5 liters of the 70s and maybe even earlier, and to a certain extent the newer ones, but there were some significant changes with the fuel injection system, so it may not be completely identical. So the question now is, how does it actually work? Well, we have our fuel distributor up here, which has a supply line that is the left one, and then the return line coming out of the pressure regulator, going all the way back to your fuel pumps, fuel filter, accumulator, and the tank, the rear assembly basically. And you have 8 outputs, and when this plate is in the resting position, if it is adjusted properly, and you also have adjusted the Allen key correctly for your plate resting position, then there is no fuel coming out of any of the cylinders. And it is a fairly straightforward system of what they developed. It looks a little bit crude by today's standard, but it worked, and it still works today with relatively little or no problems if you maintain it correctly. This here is the fuel pressure regulator, which is in the return line, and there is a vacuum adapter on the backside. And most of the time when they get old, that vacuum hookup breaks, and you can get a new one for $4 from Mercedes-Benz. You take the old one out and you pry the new one into the opening, and you connect the hose which goes to the air filter hose, which connects back here. You can test this really easy with just, once you have the new adapter on there, that vacuum, that rubber piece, you hook up your vacuum pump, your manual vacuum pump, and it should hold the vacuum. You will hardly see any performance issues or changes whatsoever, because this actually is in the return line. It can just increase or decrease the pressure at very high RPMs when there's enough vacuum going through it. Now, the way this system works, it goes basically from the top down with the airflow. So on this side here, we're starting to have a negative pressure, and I will get to this in a second. The plate pushes against the piston of the fuel distributor. That in turn opens up the fuel flow to all 8 ports. The only port which has constant fuel pressure as soon as the fuel pump runs is the top one, which is the cold start valve, which sits on this connection point here, which is empty right now. And we're going to get to that a little bit later. The way this now works is, when you start the engine, you have 8 fuel injectors. 1, 2, 3, 4, 5, 6, 7 is hidden behind here, and then 8 back there. They are sitting in a plastic thing like this here. They have a lower part and an upper part. Let me see if we can rotate this a little bit. Basically like this. The injector goes in from the top. There's an O-ring around here which sits in that cavity in your engine intake on the head, and then this here is where that black rubber hose basically hooks up to. And on top of it, you have this seal, and the fuel injector goes through. They go on very, very difficult when you replace them. It is good. I usually use a little bit of water with some moisture. Water usually, because that will evaporate later and make it wet, and then push the fuel injector through without damaging this part. And this part then will snap in to this top part. You will hear this, they will physically snap in, and this part will physically snap into the cylinder head. Let me see if I can show you this better. I don't know. I have some pictures here. Let me see if we can get a close-up here. Whoops, I'm sorry about this. Yeah, you can see the three parts. You have the top here is your fuel injector. You have that upper part and that lower part which sits in your cylinder head right next to the cover. And I don't think I have a picture where this is actually open. And what happens is, of course, they dry out, the rubber gets brittle, and they're starting to leak air. Now, the whole system actually starts here. When you crank the engine over, the vacuum is generated on these output ports. These little things here where the hoses hook up to. This is what's going to determine your idle speed. This part right here, this connection. So if you have a leak here or on top, you will bypass the vacuum, and that will get then not enough fuel going. So they get then sucked through this hose, then from here over here to this T hose where both sides connect. This hose connects to this metal adapter. It just sits on the upper intake manifold. And then on this side here, you connect your idle speed control valve, and the idle speed control valve goes down here. So the vacuum flow, or the airflow, is down. Throttle plate is closed. That means there's no way anything can go below. Exit point for vacuum, and then it goes through the idle speed control valve, through this hose, through the cylinder, wherever the intake valve is open at that point. So you can have, this is the first point you have to actually redo on most older cars. I would say that is a maintenance item which probably should be replaced every 5 to 10 years at the very latest. And this hose here, this connecting hose from this side over to the other, is somewhat tricky to get. It's easy to come out, but it is somewhat tricky to get back in. These ones here, you can just pull them out, and they have end caps on them. I don't know if we got a picture. I think so. This here is the end cap for what it's worth it. Just a rubber plastic plug. They usually dry out too, and then they're starting to bypass air here. And that is usually your scenario. So if you have an air leak on these ports or on the top of this here, that means there's not enough vacuum going to pull the plate down, so you don't have enough fuel flowing actually. Okay, so once you have this fixed, then you have your idle speed vacuum you actually should have and need, and that the ICV, or the idle speed control valve, should be able to regulate this. And this here is the connection for the vacuum advance on the EZL unit. This is directly the intake port on the 5th cylinder. This is what I was talking about, because that's where this whole system basically lives off. And now, in order to understand this better, the intake system is comprised of 2 units. The lower unit, which has the throttle body assembly with the throttle plate in it, that is normally closed, and you can see the lever here. And then we have the upper intake, which is this part here, which screws onto the bottom part, and the donuts are basically sealing the upper and the lower half together. That's why they have to be absolutely sealed, and this has to be absolutely tight, otherwise you're going to have an issue like there's no tomorrow. This has to be done very precisely. And then you can see, so this is basically what's underneath it. Then you have the hose going, the connecting hose for the idle speed vacuum goes about here, and you have the 4 mounting positions for your fuel, air fuel mixers, that basically, or air fuel ratio combiner, whatever. I don't know exactly what the English word is for that either, but in German it is der Luftmengenmischer. That means it's the air mixture air amount, well, it mixes the air and the fuel basically together because your fuel distributor is sitting on top of it too, but it does not spray directly in there. So that's the 3 levels. The bottom level is where then the vacuum is going through. If this plate is closed because you're not stepping on the throttle, there is no vacuum drawn out of the individual intakes. 1, 2, 3, 4, 5, 6, 7, 8. And those are the ones for the actual operation. So you have 8 ports on top for vacuum ports for idle speed, and 8 for actually driving. And that's what that switch indicates. And that's how the EZL unit knows, and the ECU, the engine, the computer, of what you're actually doing, if the car's just idling or if we're actually driving. And then everything switches over from there. And again, this is the actual port when there is for the EZL vacuum advance. And the way this now works is there's 2 scenarios basically. You don't have enough vacuum or you have too much vacuum. And there's something you need to know is, for one, is the vacuum leaks when you're driving is different. They have a different impact than when you're actually idling. And the rough idle, for many instances, depends on how bad it comes, is air bypassing or coming through somewhere where there's not supposed to. That's the common philosophy, and this is based on this here being all rubber parts and plastic parts and rubber seals and so far and so on. To replace these 3 hoses or 4 hoses with new plastic adapters for end caps and the seats, I would say, and I would strongly suggest to buy only Mercedes-Benz parts, because the other ones you will have nothing but problems with. Around $150. And then the 2 new hoses here and that adapter, that plastic adapter here for this, to connect the ICV valve to the boot of the air fuel mixture ratio or air mixer. Then you have most of it already pretty much tackled. The 3 ports in the back, they get their vacuum from the top manifold, and they will take this off the intake. So this will have a different impact when they're leaking than when these here leaking. And now the question is to figure out, do I have too much vacuum or do I have too little vacuum? Well, usually with the little vacuum, when you don't have enough vacuum because this stuff here is leaking, then you usually have already a problem starting the engine hot or cold to begin with, because this plate is only sucked down by vacuum, which goes through the idle speed control valve, which is fully open at this point. So the entire vacuum drawn, which is not much, you're looking at 15-inch mercury, maybe 17-inch mercury. It's not a high amount. And then the other thing is, of course, you need to check your fuel injectors, that they have an even spray pattern, and that the fuel distributor puts out an equal amount of fuel. That means that they are working correctly. This thing doesn't like at all, and that's why their lifespan is usually only 10 to 15 years here in the United States, is ethanol. There's a gasket in the middle between the upper and lower half, which is very thin, and this gasket deteriorates. It opens and closes these spring-loaded valves to the cylinders and regulates the fuel flow evenly. And they usually go bad, and then you have one cylinder leaking. The other one is the O-ring of the piston itself. It has 2 or 3 O-rings on it, and they start to leak. The way you can see this is by pushing the plate down when the engine is not running and the fuel pumps are off. You look in and you use a flashlight, and on the bottom of the boot, which goes down in this direction here towards the throttle, you will see streaks of fuel, of dried fuel. You will see fuel residue. And the failures are coming from ethanol. That's what I can tell you, because those things were not made. This is pre-ethanol days. So if you're running 10% or higher ethanol in these cars, expect to rebuild them probably every 7 to 10 years. That's about the interval on them. The fuel injectors are a little bit better, and I don't know if Bosch changed them now to be compatible with ethanol or not, but I wouldn't take my chances with it. That's why I'm getting 91 ethanol free at the gas station, even though I'm paying a premium price. Now, if you're looking at this picture and you're looking at your car and you have like an 86 or 87 model, 4.2 or 5.6, then you will see that this is not ripped here. This is the newer version, and you will get only this as a replacement. And they have also shortened this hose here. They used to have two short connectors connecting this together, and they found out that this was actually choking off the vacuum, which caused then a stutter and a rough vacuum, and the car would have a huge hesitation to actually run when it gets warm. So they used the two longer ones, and they're somewhat difficult to find. If you can't find them, contact your Mercedes-Benz dealer. They can get you the exact parts you need in order to fix this. These ones here are commonly available. The reason why I suggested you go to Mercedes-Benz is because they have a date stamp on there when they were made. And you don't want a part which is 15, 20 years old, which sat in some warehouse in Arizona with no air conditioning, and you're paying $18, $25 for it, and then it gets there and it is barely better than the part you're replacing because it has dried out in the warehouse, even it is a Mercedes-Benz part. At least with those parts, you have an indication when they were made, where they were made, and for how long they had actually been sitting in a warehouse. You do not want to get these parts older than 5 years from any source, because otherwise they're going to be nearly as dried out from just sitting in a warehouse, especially if the warehouse wasn't climatized. And then you're putting a bad part in there. Basically, you're replacing a bad one with a not so bad one. So go to Mercedes-Benz straight, get them from the dealership, get them with the newest dates. They have the stuff they can have, that they're in stock, and then they're available. This hose here is critical because the new one has an improved ripping on it where the hose can no longer collapse under vacuum. That has happened too, and that's why they changed it. Make sure that this little connector down here, this here, holds this firmly in place, and make sure that this part is not worn out. That means if you put the hose on, you want to have a resistance on there. If it goes on really, really loose, you may have an air leak here. And again, this is the port for the cold start valve. This is the hookup on this side with the clamp on it for the idle speed control valve, which basically connects in an L, and it has that bypass piece in here. And this is the breather hose from top of the left hand. This is this hose here, which I've bent to the side. That usually goes on top there, and it has a clip on it. This is here B11.2. This is the water temperature sensor. This is the switch, the water temperature switch for the vacuum for the exhaust, or not the exhaust fumes, but fuel fume, carbon canister system. And this is your EGR valve. This one goes on top of the throttle body port. This one goes on the bottom one, and then on the other side next to it they have the big one. That's the black hose going out. That's the main vacuum for the carbon canister. That's where all the fumes are going to be sucked in. All the other three ports in the back for the transmission modulator, for the AC system up here, and for your vacuum gauge, and the one to your brake booster, are living off primarily of a cylinder number 4 in the back. And again, the firing order for this is 1, 5, 4, and then I gotta see 8. And this is where now the issue comes from with the increased idle. And what happens in these engines, and that is very typical, is that you have the water pump up front. That means that the cold or coolant temperature is coming out in the front, and then it goes through the engine, and by the time it goes through the back, these are the two lines back here which go into your heater core, the pump, and that mono valve you have in the back there. That means that cylinder 4 and cylinder 8 always run hotter than the other ones, and 8 is mostly affected. And the way you can tell this is when you have an older car and you take off the valve covers and you look at the oil distribution rail on top there. They have 1, 2, 3, 4, 5, I believe, connections, which are just plugged in to the camshaft holders and bearing assembly. That is an oiled bearing assembly. That's where they're spraying in. And what will happen is they pop out in the end at the rear. They always come out because that's where the most heat is, and that's where they shrink on both sides. 8 is worse than 4. So when you can actually usually come in and just start lifting them off, and then you will see as further you work your way up front, as harder it gets when they come out. That happens around 80,000, 100,000 miles before your chain is actually going to go into the to chain heaven. That happens around 120,000 if you're not careful, and so do your rails, the guide rails for the chain. With that being said, this is basically, again, the flow. The vacuum is created here. 1, 5, 4, 8, 6, 3, 7, 2, I believe, or 2, 7, something like this. And then that creates the vacuum here. And this is the issue with the heat now, is that the valves open and close longer, or they have a longer duration, and that creates more vacuum. And that goes in the sequence, and that's when your indication here is going to go up too. But you see this with the increased idle speed at about 800, 900 to 1,000, not the 1,100. If it goes to 1,100, it's your switch. This is your switch connection down here coming from the throttle. This is when your switch gets stuck. That was what I did in the other video and how to troubleshoot this. But if you have this issue I have, then you know the issue is sitting back here. And I know this for sure because I changed the oil rails, and it was exactly in that sequence. 8 came out without anything. I could just lift it with the finger out. Whereas the 5th cylinder, I really had to pull it out, and 4 was better. I had to pull harder, and with 1 I had to use actually tools. 2 and 1 I had to use tools. 3 came out by hand, 4 came out. So when you lift them up from the rear up, you can see they come real easy, and then it gets more and more difficult to get them oil railers, the oil tubes out, oil feeding tubes out. And that will tell you this. So the higher vacuum comes now, and most likely valve noises and everything else comes from the higher heat in the end of in the rear of the engines. That means these 2 valves, in my particular case, are going to be more worn out than the other 6 valves, intake and exhaust. And when they wear out and they don't seal right anymore, then you have basically a constant kind of vacuum system going here. And because they come right after 5, you got then 4 and then 8. You have basically an increased vacuum in these lines, and that is the indication. I checked some more today on my maintenance records of what were done, and I found out that the car had major work done, and that's when they put this replacement or overhauled fuel distributor in, was in 2007, when the car had about 230,000 miles. And that was at the Mercedes-Benz dealership in downtown LA, Mercedes-Benz of Los Angeles, I think it is now. They replaced this, and they also did work underneath it. That's the marks you saw on my piston rods down there, the check marks on it and what they had replaced. And that was the last major overhaul on the engine about 100,000 miles ago. And then the last owner, the owner before me, this was the second owner before me who did that repair. That was not cheap. They did this part, and they definitely overhauled the heads. That's why I have the same shims on all 16 valves. It has never been adjusted since, and this is all now 100,000 miles later. So I have to pull the engine out sooner or later and redo that stuff, get the heads done, check the pistons and all of this good stuff. But for the moment, I have a minute vibration in it, which would be normal after 100,000 miles. And the culprits are 4 and 8 because of the water flow, the internal water flow. It's colder up front, hotter in the rear, because you want hot water. And then especially in the summer when that is just bypassed, then you have more heat build up. In the winter, when you turn the heat on and it goes through your radiator, not the radiator, the heat exchanger, the heater core, then the engine runs significantly cooler and I have less of a vibration in it. I can feel it. So when I turn the heat all the way on, so I know definitely this is these 2 cylinders, and that means that the engine itself is due for a head job at least. But that's basically how it works. Air in here comes out of this little hole at idle, goes through the idle speed control valve, goes in here into this housing. Let me show you this nicer. So air enters here from the air filter, comes out here because the plate underneath is locked. It basically closed off the connection here between all these 8 imports from the upper intake manifold. They're basically out of the picture at this point. And then it goes through the idle speed control valve on the front and comes out. Vacuum goes into this direction, is being sucked through. Here, if you turn on the cold start valve, it will add fuel into the intake system to all 8 cylinders while it is operating. This thing here you want to make sure is not leaking, also because otherwise you're going to get bad air in it. And that means that you have to make sure that this hose is connected good and that your valve cover is tight and sealed on there. And then it goes here into either one of those ports and they go through and they will suck the air in. And that is basically your air control system or the vacuum control system for the idle. And again, if you have problems with starting cold or hot and you have a rough idle or a very bad idle, then you need to check these hoses here, the seats, and that stuff. If you have a higher, if you don't have a problem starting hot or cold, then, and you have a higher idle, say like between 800 to 1000 in that range, then you're gonna have the valve issues I'm having, which comes, I would say, starting, depends on how well the engine was maintained, 75,000 miles, 100,000 miles. I'm like 92,000 miles into this, and that would be normal. That is the aging process you see in there. So these heads were overhauled 2007. This is 2021. So that is 14 years ago, 92,000 miles on it. I'm now on the 3rd fuel distributor on this car. Total mileage is 333,000, now 58, I think, or almost 333,100 miles. I think I drove quite a bit today. And that's pretty much it. Make sure that everything is good, that you got everything working the way you need it. And if you keep these here in a good shape and you buy the Mercedes-Benz parts, it won't break the bank. This is real easy to repair. It hardly ever goes bad. Just get a new nipple, the rubber attachment for that. I think I paid $3 or $4 at Mercedes-Benz. The old one had already broken off and the new one is soft, and you can just turn that into the opening and it will seal it. And then you put your vacuum tester on it. You will see the membrane holds the vacuum. Everything is fine. This thing is 33 years old now, 333,000 miles on it. The potentiometer on the airflow, for the airflow meter, that is probably something need to replace. And the EHA valves, they're 2 halves. They have a membrane in there, a seal. And also, again, this is another part which doesn't like ethanol. $430 I paid Mercedes-Benz for a new one. Don't buy a used one because they had ethanol in there most likely. And that's another one. You're replacing a bad part with a not so bad part. It will be only a matter of time. Life expectancy normally 10 to 15 years on these parts here. Probably the same for the fuel injectors. If you're not running ethanol, with ethanol, I would give it a time span of 5 to 10 years where these parts have to be either be replaced or overhauled, just that you know what you're looking at. One more item which is overlooked, which I couldn't show you, which is hard to see, is this spring here. This is the one which keeps the throttle basically closed when you're at idle, and that keeps that switch happy. And you have to make sure that you have play in the linkage here. This is the linkage coming up to the throttle plate itself. That is pulled up by the spring, and this is the other critical part back here. That little wheel back here needs to have a clearance to this mechanism, which is operated by your accelerator pedal. And there's an adjustment you can make, and you want about 1 to 2 millimeters of play between this bracket and that roller part. And this is still good on my car. I re-greased all of these. And the other part which also goes bad, this is a plastic round piece which sits in here, which holds this basically in place to this bracket. They cost $4 or $5. They tend to break and become brittle, and that is also still working. I got a new one in there. I overhauled that at the same time. This is where the air hose hooks up, which hooks up to the underside of your air filter, and that has a port on it which has a hard vacuum line going over to the rear side of your, I hope you can see this because YouTube sometimes cuts this down. That goes to the connector here for your pressure regulator. They call it a pressure regulator, and all what this does, that pressure regulator, is it at very high RPM, there's enough vacuum going through this line here at high RPM from the air filter, because the suction goes down, and that will basically pull that off, and it holds the fuel back in the fuel distributor. That's all that does. It basically cuts off the return line. It's basically a switch, or they say pressure regulator. It's not a working pressure regulator, but it will build up the internal pressure at very high RPM. Say, like, I think that starts at about 4,000, 5,000, something like this. This is something you hardly use that part. That's why they usually don't go bad, because they're never used here in America. If you drive at 130 or 140 miles an hour and you're close to 5,500 RPM, this thing would be activated, and it will reduce the flow back, and it will increase the pressure here, so you have more fuel available going out at those high speeds. You know, that's basically what this thing does. At low RPMs, with our driving here 70 miles an hour, you could literally disconnect this part altogether and just connect the return pipe straight to the return outlet on here. One other thing is, when you have a car which set for a very long time, for one, is the ethanol is going to have clogged everything up in there. That I'm almost certain. This input port here has that screw in here, and that is actually a filter, a fine wire mesh filter, and that will basically clean the intake, or that's the last stop for anything coming from the tank or from the fuel pumps after the fuel filter. That's a secondary fuel filter. And this can clog up, especially when you had ethanol in there and the car didn't run for like 3 months, 2 months, 3 months. There's a good chance that this thing is clogged up, and either you have to get a new one or clean it out really well. Here again, you can see this. These are the long ones, and if you have the short ones in here, just remember this to order them. If your car has the short connectors here and that long hose going over to the other side, this would be a short connector here too, like this one here. Then you know when you order the replacement, you need 2 of these long PVC connectors. If you have these ones here and here, then you have to order these 2 with the new hoses, because the old hose styles are no longer available. And that should get you at least going. And this is basically the introduction to the K and KE fuel injection system and how this works. And yes, the Luftmengenmischer, the air mixture regulator here, this thing basically provides fuel to all 8 ports at the same time. So there's no sequential injection like you have it within fully electronic injection as you have it today with valves. They divide this. That's why that is a divider, also called a divider. It will allow an X amount of fuel to go through proportional over time according to the RPM. And that plate will move. This is exactly calculated. That's why the vacuum balance has to be absolutely right for this to work. When the vacuum is correct from the valves timing chain, you know, that the valves open, close correctly, and all the other vacuum related port stuff is fixed, then these engines perform like there's no tomorrow, and they will run into doomsday. When they go off valve from high mileage, or old rubber parts, plastic parts on the intake system, then this whole thing gets its little shaking and rattling and rolling, and it can get pretty bad. So you have a two defense mechanism is valve, check your valves, that they're good, open, closing times, make sure you have the good timing chain in there, make sure your timing chain tension is good. You have a heavy oil in it because the timing chain tension is oil operated, completely oil operated. The spring has virtually no strength in there, just will keep that chain a little bit pushed out. But when you start this, that oil pressure has to be there in order to fully tighten the chain into position. And that's why I still have to fix here on my right hand side the offset, because that will improve my idle too, because it is off like by 2 to 3 timing degrees, and we will get that eventually sorted out. But eventually I will have, at 100,000 miles, I will have to rebuild this. I got to think about it, and I'm probably going to do this when I get 350,000 miles, which would put me about 17,000 miles out. But if I fix this here, then I will maintain the engine in a very, very good shape, and I can get easily another 17,000 miles out of it without any major, you know, vibrations. I have mild little vibrations in there from that, and that increased idle RPM is coming, like I said, is from 4 and 8 cylinder, because of the valves and the carbon built up after 100,000 miles, and this, that, and the other thing, and eventually we can take care of it. I do not know how well you can remove carbon deposits from valves on the intake, you know, while it is in the car. If you just take the covers off in the intake manifold, you can see the ports, you can see the valve stems on all valves. This is the intake side here, and of course the exhaust side is on the other side. I haven't taken that off. I haven't bothered taking the exhaust off and taking a look at the valve stems there, but they may have some more on it. You know, that may improve it, but eventually I will have to do it. So 350,000 miles is the target. When we get to this, that's when we're going to pull engine and transmission out and do a complete rebuild on this, and then the car should be good for another 15, 20 or so years, you know, if you use high quality parts and you park the car indoors and that sort of stuff. Yeah. So I hope that this explained now the basics on how the system actually works, what these individual parts do and what they don't do, and how simple it actually is. You know, there's no magic to it. It is different. The normal K and KE Jetronics on Volkswagens and Porsches work inverted. That means they're actually pulling the air in from underneath, and they're pushing the plate up. And Mercedes-Benz told Bosch, we didn't want it. The fuel distributor really doesn't care whether the plate goes up or down. They can make it either way. In this case, they inverted the fuel distributor for this to be pushed up, rather to come down in this direction. So the fuel distributor works inverted from the other cars. Same pretty much the same principle of it. If you can fix this car, you can fix a Beamer, you can fix a Rolls-Royce, a Ferrari, Jaguars. I mean, almost every other car had that from the 70s on 80s. That was the system they used back then with a catalytic converter and the Bosch oxygen sensor, because Bosch really pioneered the oxygen sensor. So that's where this whole thing came, and the companies which were concerned about fuel, emissions, and they were selling into America a lot, with emissions control being the heaviest anywhere in the world at that point, since the early 70s, I think. That's where this all originated from. You can work on any of them. You will understand the principle. But this was primarily a tutorial for people who are new to K and KE Jetronic based engines, suction engines, what they're called, who have never worked on them before. And I hope this makes it a little bit easier for you to understand what you bought or what you got, and what you're up against, and how fairly easy it is actually to maintain them once you get the hang of it. There's no magic to it. The rule of thumb is always fuel flow needs to be equal to each. That's an important thing. And you have to have a good spray pattern. Equality comes, the equal fuel output comes from the fuel distributor. The spray pattern, of course, from the injectors. Pressure is your fuel pump. Once you get that sorted out, and that is correct, then your intake vacuum, or the vacuum here for your idle speed. That's these 4 ports and these 4 ports. The holders, the cups basically, and the seals on top of it with the injectors in it. Your connection here, the hose connections, that they're in excellent shape, that this thing is not leaking or bypassing air. And then your idle speed valve, your control valve to begin with, that the boot is okay and not hardened out. And then the other part is just your throttle body. If you got that 1100 idle, you know what Mercedes-Benz is talking about in their service bulletin, that you overhaul it and you have to take this out. You want to make sure you have a good seal between the upper intake manifold to the actual heads, because there's water going through there, coolant water or coolant fluid, and the vacuum. That's an important thing, and that's why I said use the Mercedes-Benz gasket, $13 a piece. You won't regret it. They will seal this. I got this in with no leaks, nothing, and it didn't take long. They have 2 pins on there. You set the gaskets on. They have to seal, the right seal, the sealant on there, besides the gasket material, and you set this in there, and it fits perfectly, and you start tightening your bolts down, and you're done. And with that, have a happy Thanksgiving and a great evening.